there is no sliding between the two surfaces. That is, the point of contact between these rolling body and the surface, that is at rest. When we talk about the pure rolling, then there is no slippage between the rolling body and the platform or the surface on which it is moving. Pure rolling is always without slippage. Now let's understand the cases when this rolling body is rolling over surfaces which are themselves they are moving. And when there is a pure rolling, then certainly there should not be any slippage. That is, the point of contact should also have the same velocity as that of platform. Let's understand this. Over here we have taken three cases. Let's call it as case number 1, this is case number 2, and this is acceleration case number 3. This is a rolling body having angular velocity omega, and this center of mass is having a velocity vcm. This is on a platform. Platform is, let's say, on a frictionless surface or so, and the platform is having a velocity u. So when we say that there is no slippage between this rolling body and this platform, so it means the point of contact should have the same velocity as that of the platform itself. So if we break this motion, if we understand that is how it is taking place, so when this is rotating also and translating also, let's talk about point P. Point P is having, number 1, because center of mass is moving this way, so one velocity is vcm purely because of translation, and also because this is rotating about this axis, so that's why this is going to have a velocity because of this rotation, and that is equal to v is equal to r omega. So that is r into omega is going to be over here. Now this point is not slipping with respect to this point, so it means this point should have the same velocity as that of u. So now the net velocity of this is superimposition of vcm and r omega. Ultimately this point should have velocity u in this direction. So it means in this case vcm minus r omega, that should be equal to u, if there is no slippage and if there has to be a pure rolling. So the net velocity of this point is superposition because of translatory motion and because of rotatory motion. Because of translation, it is having the same velocity as that of center of mass, that is vcm. Because of rotation, it is having velocity this way, r omega, and ultimately this should have the same velocity as that of platform, and it is in this direction. So this velocity should be greater than this velocity, that is vcm minus r omega, that should be equal to u only. If this is the case, then this body will not be slipping or skidding over this surface. Now, if platform, instead of going like this, it is moving in this direction, then once again the method is same only. So if this is vcm is in this direction, it is rotating like this, so it means r omega is in this direction, and once this is because of rotation, this velocity is because of rotation. Because of translation, this point will have velocity vcm over here. Ultimately we say that this point is stationary with respect to this point at that instant, so this point should have the same velocity as that of u. So now in this case r omega should be greater than vcm, because ultimately now the net velocity of this point should be in this direction, and that should be equal to the velocity of platform itself. So r omega should be greater than vcm, so r omega minus vcm should be equal to u. Now if this is an accelerated surface, for this accelerated surface, once again, if we don't want that there is any slippage between these two, so one is, this is having acceleration acm. If acm, then because of this translatory motion, it is going to have acm in this direction, acceleration. Apart from this, this is having alpha, so a tangential is equal to r alpha, it will be in this direction, that is r into alpha. Ultimately we want that this point should not be skidding with respect to this platform, so the net acceleration of this point should be same as that of the platform. In this case, if there is no skidding between, there is no slippage between these two, so it means net acceleration should be in this direction, that should be a, so that's why this should be greater than this. That's why acm minus r alpha should be equal to acceleration of platform. So in this case there will not be any slippage between the two surfaces, and then there is going to be pure rolling of this body over the moving platform.